Good morning everyone, this very cold winter morning. So finally back at this job, which I had to suspend because of my broken thumb. So just to remind you, we are splitting off the ring final and making it 2 radials in here, so the garage door is on its own RCD, so we're separating the lightings and everything else. Right, let's just pull that up. So I'll pull that out a bit, there you go. So that's how the board looks now. And as you can now see, I've now labelled it all up. So we've got the sockets in the garage, which is in this section on this RCD, with the inside lights, and on the other RCD we've got the sockets that's below this consumer unit, which will change later, the outside lights, and the sockets in the rear room, which will end up powering all the lights in the garden as well. So the garage door is now on the garage sockets there, and everything on the outside is on the other RCD, which is exactly what the customer wanted. So like I say, there's one more thing to do, is this here, that single socket down there is coming off there and it's going on there, and we'll do that in a second. But what I need to do is the testing, and I'll show you that next. Very quickly, to show you behind this socket, the linking cable, which is actually, there you go, that's what went through the wall to the plug socket on the other side there. That is what made this a ring, going all the way around both rooms. Taking that out has in effect made this now 2 radials. So this is now the radial in the garage, and the other side is the radial for the back room. Now when I do the testing, this is now the last socket on the radial circuit. The socket on the other side of the wall, which I'll show you in a minute, is the last socket on that radial. That is, these are where I'll be taking my readings from for the R1, R2s and things. I can do an insulation resistance test on the ones next door. I can't do it on this one because I can't disconnect the garage door, and I'm not going to risk damaging it. So I can't do the IR test on this, which is a shame. But I'll put that up in the paperwork as a limitation. I don't want to risk damaging the door in any way, shape or form after all the hard work we've done. So I just wanted to show you that. So that hole there is where the cable used to go through the wall, which I've taken out. So this is the socket where I'll do the R1, R2, and I'll show you how it's all connected up in the board in just a second. Okay, so back in here again. Well, right, so that 20, that one, is the new one I put in for just being able to split the radials off. So you can see over here that 32 has now got nothing in it. That 16's got nothing in it, but it didn't have it anyway. So we've got a 20 at the end, which now has just the one cable in it, and we have a 20 here, just has the one cable. And I've also done the lights as well. So you'll notice that smaller 1mm cable. Oh, let me just grab it. You'll see that smaller 1mm cable up there. Okay, that's controlling the outside lights, and that's why it's on there. And then what we've got over here, the other B6, I've lost it, there it is. You'll see it's got 2 cables in it, that's controlling all the inside lights. Now, that's why I've done all that. So effectively everything inside is on one RCD, everything outside is on the other. Now this 16 rather, sorry, has got the that socket. So what we're going to do, we're going to move that cable on that 16 over to that 20 over there and plug it into there. That's perfectly okay to tee off on a radial, that's perfectly fine. So we'll do that. But the other thing you've got to remember when you're doing this, when you're moving things around, is don't forget to move the neutral, because it's now going to be on another RCD. So the neutral has got to move from the neutral bar on the right hand side to the left hand side. Don't forget to do that. So we're going to move that cable first, and then we'll do the testing, because there's no point in doing the testing until I've got a complete proper radial in here. Then I'll get proper readings then. Like I say, I can't do the insulation resistance in here because I am not going to risk damaging that door. Okay, let's get on with that then. Sorry, as I'm here, because one thing I haven't done is I'm going to do the ZE in it LPF tests. Now that means connecting onto that black wire there, so that earth wire that's black, and to the top of those, because that's the incoming line, so that those two are live. Yeah, so I'll be connecting to those port up to there, and that'll give me the ZE and the LPF tests. Now the ZE here will be the ZE that's this board cable to the other board added together. So yeah, I know that sounds confusing. I might have to explain that in another day, but effectively what I'm doing is getting the ZE and the LPF. So those are the readings I got. That's the highest reading, 407 amps, which should be 0.4 kiloamps on the form, and 0.6 ohms. That's absolutely fine for this installation. Like I say, that's adding both boards together, the main board and this one, so that would be absolutely fine. The paperwork only needs me to put this down because this is the board I'm working on. So that's the figure I'll be using to do all the calculations to make sure all the other installation resistance tests come out absolutely fine. Right, so we'll get on then. So we're going to do the R1 R2 here. Right, so we've got the leads connected to the line there on the garage circuit to the CPC on the garage circuit. Come down the ladder. Just come over here. So this is all connected up. I'm using the blue because my green isn't working at the moment for some reason. Doesn't really matter as long as the leads are connected. Connected into the box. Just press button. It's 0.18, and there we go. So that's quite happy with that. So we'll now do the radial in the other room. I was absolutely right in what I would find. This was 0.32. I've remembered now. This is the furthest away. This one was 0.2, and then that one was 0.15, because that's the closest to the board, and it's exactly what you should see. So that's fine, I'm happy with that. So, okay, anyway, so that's the radial test done. So that is that for in here for the time being. I now need to go and scratch my head over what's going on outside, because I can now work on the outside without any problem. Now, as you remember, that was the peculiar mess of cabling going outside. Now fiddle with this to our heart's content. And do that. So now I've got all the information I need. Oh, I'll tell you what I haven't done out here. I haven't done the installation resistance test. I'll do that next. Okay, just did the IR test next door. Yep, absolutely fine. Greater than 2,000 mega ohms on that. Not a problem. Both on the line to neutral, line to CPC, neutral to CPC. Did all three. I know you don't need to for the paperwork on the test sheets, but I did it anyway, and all of them came out the same. And I'm not surprised because it's brand new wiring. I'll be hugely shocked if any of those have failed. Like I say, I can't do it in this part of the room because of the garage door, which you can see behind me. And my lights failed, which is not great because I charged that last night. That's not helpful. Right, anyway, let's get on. Right, just one thing. Hang on, let's just turn that. There we go. As you can see, I didn't put that radial in because you probably can't see from there, but that screw at the top of that circuit breaker has been stripped, and there is no way I could get that out. That's been over tightened. You can probably see the difference between that one and that one. It's been totally stripped. There's no way on earth that's going to come out of there. I'm going to have to, in order to do that, I'm going to have to cut that line conductor and remove that, because that's no good to man or beast anymore. I don't know what someone's done to that, but that is totally stripped. Oh well, there you go, what can you do? So this is the inside of the socket, and someone's obviously tried to increase it to be on the ring, but not done it right. So let's have a look at this. So what I'm going to do is work out which of these two cables I'm going to reuse and disconnect the other one, and see someone's earthed it to the plastic box. Yep, that'll work wonders. And you can see the outside of this SWA cable hasn't been earthed in any way, what shape or form, so that'll have to be dealt with as well. Anyway, let's work out which of those is which is going over there. Those two cables in there, so let's work out what's doing what. So these are the two incoming lines into this junction box, and what they've done is they've got a cable here going to a 3-pin and another one going to a 3-pin, and what they did was they plugged it into there and into the rest of the electrics, and they wondered why it didn't work. I mean, why? That's all I can say. Why? Oh well, let's get all this entangled mess of whatever you want to call it and see if we can get some continuity. Ah dear. This is not what I was expecting. Okay, I've got these, I've got the line and the neutral conductor connected there, and as you can see I'm getting continuity, but it isn't to the plugs. It's actually here going to the lights. You can see it's in a very poor state in there. So the other one I've already checked is actually going over there. It goes to the I'll check that again in a second, but I think it's the right hand side, I think. So I've got a bit of a mystery as to where that other cable there goes, and there is a second cable in there. You can just see it with a much thicker cable, but that could be that cable there that you can see that's actually disconnected. I think I'm going to get my label and label these up so I know where each thing is going, but it's not what I was expecting to see. So we have a mystery as to, we've got a cable there going somewhere and a cable there going somewhere. It's not what I was expecting. It's what I love about this job. So label that one up there. That one on the right is going to the lights, and the one on the left is going to the socket. Just show you that. I'll just show you the socket. It is the one cable on the right that's going to the cable on the left. So I'll just label that up so I know what we're doing. So the cable on the left in the socket, we don't know where that's going yet. Okay, I'm going to video this to try and make sense of it in my own head. So I think this is the history of what was done. So originally, let's go outside. So as you can see, we have this cable here that's cut. That is just a 2-core red and black cable. This is a 2-core red and black cable. So that is that. So originally that probably went into the garage, and that's how these lights were originally powered. Some point after that a newer cable was put in to power the lights. Came over here, and this is what this red and blue is, and the earth. With the earth sheath here, which is what we see in the garage. But for some bizarre reason the red and black were left connected. This was all connected up when I opened this box. So that's what was going on here. So we had a cut cable there that when it rained got wet, shorted this out, caused the RCD to trip. That's my working theory at the moment. So this and this whole arrangement here, this cabling, is all the culprit for the RCD tripping. Now the other cable is running to the socket. As you can see, I've labelled that and it's all hooked up, but I'm testing. So that's fine. I've done continuity, I've done IR testing, everything on that cable is absolutely fine. I could wire that socket back up and it will work fine. I just need to redo the junction box in there and that'll work fine. There's nothing wrong with that. That was not the culprit of the tripping. But the final mystery is that other cable that you can see there. At the moment I do not know where that goes. It certainly doesn't go back to the garage and it doesn't come to here. So it's got to be going somewhere else. Well, that's blatant obvious. So I think we found the smoking gun as to why the RCD was tripping, and it was here. And you can see how badly corroded these cables are. But that's not surprising given the fact that we've got an open cable over there which was live. It would have been always live. Completely exposed. But there you go. Okay, so and obviously we can't have that because we can't have a lighting circuit directly off a socket circuit anyway. So in order to bring these back to life, assuming they haven't been damaged by all this, I need to put a fuse spur in there, 6 amp, and then these will run off that 6 amp fuse spur. Now what I need to do is go down the other end of the garden and see if we can trace out that other cable and see where that goes. That's the remaining mystery. So you can see my test is all set up on that light over there. Now it's interesting because when I'm connected to those, there's very poor continuity, 95 ohms. When I've connected up the line and the neutral together, there's 0 on the IR reading. So there's a short on that cable somewhere underground. So there's something, it's going somewhere, but it's not connected to anything. So what I'm going to do, I've had a chat to the client, and we're going to make safe that cable. So I'm just going to Waco it off in the back of that box, because that box is nothing wrong with it, and there's nothing wrong with the other cable, so they're fine. So I can liven up that box in the right way. That's fine. As for the lights, the decision made there is we're going to make safe the lighting cable here. Probably just Waco it off and not connect it up in any way, shape or form, because what the client wants to do, he wants to make a decision as to what he's going to do with the lights and the pumps down the end of the garden. They might just be taken out, they might just be replaced, but that'll be done at another time. So I'm happy with that, so we'll just Waco that off in there. I've got a new junction box which I'm going to do. I'm going to re-terminate the SWA cable correctly there and there. Then that double socket will be live in the right way. Oh, obviously I've got to hook that the junction box up to that plug, but that's easy enough. That's not a problem. So yeah, so that's what we're going to do. This was a challenging problem. Interesting, but a challenging one nonetheless. So I've got the junction box off, so now we can see the real mess that someone's made here. And as you can see, this is not the way it's supposed to look, an SWA cable when you're terminating it, so I'm going to have to redo this. Put new glands on that one. This one, I could probably do a bit more work with that one, and probably that one would probably be alright. I'm not so bothered about this one. This is the one going to the lighting circuit, which we're not going to energise anyway at the moment, so I'm not so worried about that one. But this one is a right dog's dinner. So yeah, we're going to try and do what I can with that, I think. But yeah, I don't know whether I'm going to be able to. Have to wait and see. I've got some storm glands and stuff, so we'll see if that will go into it. We'll obviously have to trim that right back and then recut that and see what we can do. I'm not confident, if I'm honest. I might have to start all over again with that one. But anyway, we'll see. So anybody unfamiliar with this stuff, what I've got here, and I prefer using these to be honest with you, these are storm glands, which are these, and this is a whisker box. It's a 308 with an earth bar. The earth bar just fits into there like that. Oops, hang on. Just fits into there like that. These soft knockouts knock out as you screw in. You screw into that. It means you don't need to use one of those. It's nice and neat and tidy. but I do prefer using these and trying to cut the shrouds and things. I love using these. I always use these for doing SWAs. So we're going to try and use that and retrofit that onto there. And as I said, I'm not confident that's going to work, but we'll have a go. Okay. I was basically working on the wrong one there, but what I've done is I've trimmed off the outer sheath, that metal sheath. I've got rid of that on that one, but that's not the one I want to be working on. It's this one, which actually is a lot neater, so that I can salvage definitely. So that's what we want to get done. So we've got that mounted now, a new metal back box. That's all metal. That's all mounted on there, so I've taken out the plastic one. It just makes it easier to terminate everything. So we'll just get on with that and then we'll carry on. Okay, so I'll just want to show you. So here we go. So that's now properly terminated into there. And obviously I can run a fly lead from that nut to connect it all into the earthing, so I can earth the outer sheath. But that's how it's supposed to look. Anyway, so that's done. So we just need to get that on the wall, and then we can complete that up to there. Obviously, like I say, this one I'm just going to put in. I'm not going to do anything with that. That's just going to be wagoed off. We're not using the lighting circuit, so we're just worried about this one for the time being. So we'll get that all hooked up and get that all done as well. Okay, here we go. So that's all been finally retrofitted through there. So there we go. So that's the new box on the wall. And the new, that is straight, by the way. I don't know why the video is showing that a bit odd, but that is definitely straight. That isn't, the black box isn't. I'll straighten that up in a second. Quite sure why that's not straight, but we'll work that out in a second. Oh, we're getting there at last. So that's all done in there now. We just need to, obviously I've wagoed this all together to make sure that doesn't do anything at all in there, just for neatness really. That's not connected to anything, and then obviously we've got to wago these together to complete the circuit. I might tidy up those ends and get those nice and neat, tidy, and then go and finish off connecting it up in the box outside, and then we'll do our tests. I'm all done now. We're just doing the tests. So let's just see what the RCD came up with. So 1 times, 1 times, 5 times, 5 times. Okay, happy with that. Okay, so I think we're all finished. So there we go, all retrofitted. I think it looks a much neater job than it was. At least it's all done in the right way outside. So at some point in the future we'll deal with the lighting circuit, but that's all been wagoed off and isn't going to bother anybody, so that's all sorted. Yeah, so that's all done. No more RCD tripping here.